everybody. This is Davide Falessi, the Multimedia Editor-in-Chief, and today we're going to hear about architecture sustainability by Paris Avgeriou, who is a full professor at the University of Groningen in the Netherlands, and via Rich Hilliard, who is an independent consultant located in Cambridge, USA. So my first question to both of you is, what do you think managing architecture sustainability means?
Architecting the system to allow it to enable and undergo various kinds of change over its life cycle in an efficient, resource-sensitive fashion.
So why is the architecture sustainability an interesting topic?
Well, for me, there's a couple things. Before one even gets even into any technical details, the idea of sustainability, to me, is when considering a system taking into account its environment. And there's obviously a lot of cultural and worldwide interest in sustainable computing and green computing and sustainable behaviors in all kind of realms outside of computing. But even aside from all those good things, taking into account the resources that you need to create, operate, maintain, evolve a system is a good idea for most people who are interested, the owners, the operators, the users, the customers. And so that fits nicely. All fits nicely. The notion of architectural sustainability of software systems fits nicely with what we understand about sustainability in general and our understanding of architecture.
So if I can if I can follow up on that, I think sustainability is a bit of a buzzword these days. You know, we use it every day for different contexts, especially when it has to do with our sustainable planet. When it comes to software engineering, I think we have not really managed to make sustainable systems. In fact, a lot of the systems, especially the larger one and more complicated systems, are particularly problematic when it comes to sustainability. And this is quite obvious if you look at the issues that architects face these days. There are so many things that change. There are so many axes, so many factors that change inside the system that eventually it becomes rather unmanageable for architects to cope with all these changes. You know, there's a lot of new requirements while you still have to work with all the requirements. You have to synchronize the requirements and the architecture. Sometimes the company changes its strategy or its goals. Sometimes the environment changes, and then you have erosion of the architecture. You have things like accidental complexity. Well, these are problems that we have been facing for a number of decades. It's actually a wicked problem to try to keep your system sustainable. And I think with this special issue, we just try to raise awareness of this very, very important topic for practitioners out there, and try to emphasize that there is work, there's good work being done that can help practitioners manage the system sustainability. But also for researchers, there's also a lot of work to be done to help industrial practice with this very important problem.
Great. So why do you think IEEE software should cover this topic now? So what makes this topic especially timely for practitioners?
A lot of the things that Paris just mentioned and the realities of tight budgets, you know, resource constraints, short time scales, and the things that lead you to not want to have to do things over and over and over again through, you know, planning ahead, thinking ahead, building to anticipate the kind of renovation and reanalysis that's needed to, you know, to save money and to limit resource consumption.
Okay. Do you want to add anything, Paris?
Sure. Yeah, I think that it's time we actually discuss this topic because for me it's a bit of an obfuscated topic, sometimes even a little bit obscure. There's a lot of different efforts on evolving and maintaining systems, and there's all sorts of methods and tooling out there that I think the landscape is a bit clouded. So we need some more discussion. We need to put the spotlight, and we need to show what are the problems, what are the current approaches, and what can be used, what can still be improved. So there's actually quite a lot of room for improvement these days. We even make a very important differentiation in this topic that has not been done in the past. We differentiate between refactoring, renovating, and re-architecting. So these are three successive steps about how to manage architecture sustainability. When you refactor the system, it's the least invasive change. You basically change a few components without really changing the functionality, but you just improve them so that the system is, let's say, more sustainable, more open to change. Then there's a level higher than that, which is renovating. Sometimes refactoring will not just do the job. You actually need to build from scratch some of the components. You cannot simply just change them, and that will solve some more, let's say, system-wide problems. And if even that's not enough, you have to end up re-architecting, which is basically redesigning the architecture. You can always keep some of the existing components either as they are or refactored, but you have to also bring in new components and create them. So these three levels of managing sustainability are important. We need to make this differentiation, and we need to start working on all these three levels if we want to really progress and make a difference and help practitioners to better manage their system sustainability.
Okay. Anything else you want to add?
Okay, so I would like to thank the authors of the submissions that we received, which were all quite high quality, and also the numerous anonymous reviewers who did a lot of work, as well as the staff at IEEE Software for putting together a very good quality special issue.
Great. So it was my pleasure to interview Paris and Rich, and thanks a lot for your contributions.
Thank you.